Uh, Good morning, everybody. So, this is a video lecture that will facilitate you to understand the basics that you will have to know before you come for your lab session for the Prim's and kruskals algorithm. Right? I'm sure you would have learned a lot of algorithms, and these are two interesting algorithms that are very simple. And before we get into the lab, you need to know what is a graph, what is a spanning tree, what is a minimum spanning tree, and what are its applications. Okay, so with a good and sound proficient knowledge in this, you will definitely be able to move forward in the lab with an easy pace. Okay, so first, I know you would have learned this graph in our previous semester, wherein I had handled for you the graph session. So a graph, this is a typical graph, a small simple graph, right? And we know the graph, a graph G can be defined as a set of vertices and edges. So what do we mean by the vertices and edges? We have three vertices, 1, 2 and 3 in this graph. So we have written the vertices as the set of 1, 2 and 3, and the edges, if you see, they are, you can have it as 1 comma 2, 2 comma 3, and also 3 comma 1. So what you should understand here is you have a graph, a set of vertices and undirected edges. We call these edges as undirected because if you take a sample edge of 1, 2, there is no tail and no head. Okay, 1 and 2. Had an edge been directed, it would have been like this. Okay, so you will say 1 is the tail and 2 is the head, and there is only an edge 1 comma 2 and not 2 comma 1, whereas here it is 1 comma 2 and 2 comma 1. So first let us limit ourselves to the undirected edges. Okay, fine. So you see a graph, it is simple with 3 vertices, right, and 3 edges. You can also take another instance. This is also a graph. For example, you can have this as another graph. Okay, this is another graph. So you have, what are the number of vertices here? You have 4 vertices, and obviously you have 1, 2, 3, 4, 5, 6 edges. So the edges are, if you say the vertices set is 1, 2, 3, 4, and the edges are 1 comma 2, 2 comma 4, 4 comma 3, 3 comma 1, 1 comma 4, and 2 comma 3. Okay, so 1, 2, 3, 4, 5, 6 edges, and you have 6 edges. So this is another graph. You can also have another graph like this. This is also a graph. This also a graph, right? This also a graph. So if you see, it has 1, 2, 3, 4, 5, 6 vertices, and it has 1, 2, 3, 4, 5, 6, 7 edges. Okay, so now I think you would have understood what is a graph. Okay, so this is a graph. So we have seen what is a graph now. Okay, fine. So the next thing that we are going to see is what is a spanning tree. So if you have some observations in this graph, if you see, it has some cycles, it has many number of edges, it has different vertices, right? So when we move on, we have a lot of unnecessary information also when we talk in terms of cycles. Okay, so these are all undirected graphs, and it has some cycles. So when we talk about a spanning tree is nothing but it is a graph again, which is a subset of your graph G. Okay, so when I talk about the subset of a graph G, it means your graph has a set of vertices and edges. Okay, so this subset of graph, this is going to have all the vertices plus an edges, which is subset of E. Okay, so that means you will have all the vertices that are in G, they will also be in your spanning tree, but remember, you will have only the minimum number of edges that is required to connect them. Okay, so let us see the first instance. You have a small graph, so we know it has all the vertices, so we'll have all the vertices 1, 2 and 3, right? So if you see, there is an edge 1 to 2, so there is an edge, you can take this edge. Yes, you can take this edge, you can take this edge. It is sufficient now, it's connected, right? So that means only these two have come, right? So if you see, the number of edges is the number of vertices minus 1. That is the minimum number of edges it is required to connect. So this can be a spanning tree of your figure A. Okay. You can also have few more spanning trees, like you can have it like this also. So this is another spanning tree. Yes. So this is another spanning tree. Again, you can have one more spanning tree like this. Okay. So these are all different spanning trees, but you should understand that it has all the vertices of the parent graph and it has only the minimum number of edges. Remember, if you add one more edge to it, it is going to form a cycle. Okay. So this is called as a spanning tree. So I hope now we are done with what is a spanning tree. Okay. So the next thing, you should understand that all these edges may have some weights. For example, when we take this particular edge may have a weight of 2, this particular edge may have a weight of 4, and this particular edge may have a weight of 6. Okay. So let us come to the subgraphs. When you look at the subgraphs, this is 2, 4, 2, 6 and 4, 6. So if you look at the weights of the subgraphs, right? So this is equal to 6, this is equal to 8, and this is equal to 10. So if you see here, this is minimal, right? So this is what we called as a minimum spanning tree. I hope now you have understood the term minimum spanning tree. Okay. So this is called as the minimum spanning tree. Okay. So now let us look at some of its applications. For example, I would like to talk about a very practical scenario, that is about the plumbing that happens in houses. So we all know about the plumbing, the water pipes that has to come to the various bathrooms or that we have, the washrooms. We may have 6 maybe in a house, and we would like to see the weight of the pipes. The weight of the pipes may be in terms of the length that is required. Okay, so this is a practical, understandable example that you will know the application of it. Okay, so we want to calculate this minimum spanning tree. Okay, so to address this issue, we have 2 algorithms that are called as Prim's and Kruskals algorithm. Okay, so dear students, kindly go through this video and ensure you know these 4 concepts, so that when I meet you in the next session for the lab, we will have an easy understanding of our output. Okay, thank you for listening to the video.